Hey everyone, and welcome to another deep dive. We're going to be looking at serverless computing architectures today,
Ooh, very cool.
specifically how to make them blazingly fast and super efficient.
Awesome.
We've got some really fascinating research to unpack today
Okay.
from Jan-Johan Stokovic.
Okay.
He did his PhD work at the University of Illinois
Oh, very cool.
and really kind of pushing the boundaries of what's possible with serverless.
He's doing some really groundbreaking work.
Absolutely.
It's really challenging, like the status quo in cloud computing.
Right, and we're going to be looking at a presentation that he gave
Okay.
where he dives into 3 of his key research projects.
All right.
So we're going to be talking about Micromanicore, Echoes, and Mosaic.
Very cool.
So buckle up because we're about to get into some seriously cool tech.
Yeah.
Now, even if you're not a developer, I think you've probably experienced the frustration of like a slow app
Oh,
or
yeah.
a slow
Yeah,
website.
for sure.
And in the world of serverless, one of the biggest culprits is something called tail latency.
Right. Tail latency is essentially the response time of the slowest requests in a system. So, even if most of your services are running smoothly,
Uh-huh.
a single sluggish service can create a bottleneck and just like drag down the entire application's performance.
So it's like a chain reaction.
Exactly.
Where one weak link can bring down the whole system.
Yeah, and especially in the world of microservices,
Right.
where applications are broken down into these small independent units,
Uh-huh.
this problem becomes even more pronounced
Right.
because you might have dozens or even hundreds of services working together.
Wow.
So any delay in one service can ripple through the entire system.
Yeah, that makes sense.
Yeah.
So how do we combat this tail latency monster?
Right.
Johan's first project, Micromanicore, seems to offer a pretty radical solution.
Micromanicore is a fascinating approach.
Okay.
It's a completely new type of processor architecture designed specifically for serverless workloads. So instead of having a few complex cores, like traditional processors,
Okay.
Micromanicore uses what Johan calls villages of simpler cores.
Villages of cores, that sounds intriguing.
Yeah, so think of each village as a self-contained unit
Okay.
with its own dedicated hardware for handling tasks like scheduling and switching between different requests. So this eliminates the need for software to manage these tasks, which can be a major source of bottlenecks in traditional systems.
So by handling these tasks in hardware, Micromanicore is streamlining the entire process and reducing the potential for delays.
Precisely. The
Wow.
results are pretty impressive.
Okay.
Johan's research shows a 10x reduction in tail latency and a 15x improvement in overall throughput compared to conventional server-class processors.
Those are some serious gains.
Yeah, it's a significant leap backward in performance.
So this shift towards specialized hardware, is this something we're going to see more of in the future?
It's definitely a trend to watch.
Okay.
As we moving towards more specialized workloads, whether it's serverless computing, artificial intelligence, or high-performance computing,
Right.
we're going to see a growing need for hardware that's specifically designed for those tasks. It's a departure from the one-size-fits-all approach of traditional processors.
Right. So Micromanicore is all about speed.
Yes.
But what about efficiency?
Right.
Doesn't all this extra processing power come with a hefty energy bill?
That's a critical consideration,
Right.
especially with the growing focus on sustainability in the tech industry. And that's where Johan's next project, Echoes, comes in.
Okay.
Echoes is a software framework that's designed to significantly reduce energy consumption in serverless environments.
So how does it work its magic?
It leverages something called service-level objectives,
Okay.
or SLOs, which are basically performance targets defined by the user for a specific application.
Okay.
So Echoes uses these SLOs to intelligently manage core frequencies and power consumption. So if a function isn't actively processing requests, Echoes can lower its core frequency or even put it to sleep, saving energy without sacrificing performance.
It's like a smart thermostat for your serverless function.
Exactly.
Constantly adjusting to optimize energy usage.
Yeah.
But does this require any specialized hardware?
Nope. That's the beauty of Echoes.
Okay.
It can be implemented entirely in software on existing serverless platforms.
That's a pretty big deal.
Yeah.
It makes it much more accessible for cloud providers to adopt.
For sure.
And it highlights this growing trend of using software to optimize energy efficiency in data centers. I wonder if we'll see this kind of slow-driven resource management become more widespread in other areas of computing as well.
It's certainly possible.
Yeah.
As energy costs rise and environmental concerns become more prominent, the need for intelligent resource management will only increase.
Absolutely. Speaking of making the most of resources, Johan's third project, Mosaic, takes on the challenge of squeezing even more performance out of existing server hardware.
Right. So Mosaic tackles a really interesting problem.
Okay.
You see, serverless environments are constantly juggling multiple functions on the same hardware. And this constant switching between functions can lead to inefficiencies in how the processor uses its resources.
Oh, okay. I'm intrigued. What kind of inefficiencies are we talking about?
Imagine a whiteboard that gets messy when different people use it without erasing their work.
Oh, yeah, for sure.
Right, so that's kind of what happens inside the processor.
Okay.
There are these structures,
Uh-huh.
like caches,
Right.
translation look-aside buffers, and branch predictors that store information to help the processor work faster.
Mm-hmm.
But when different functions are constantly switching back and forth,
Right.
these structures get filled with irrelevant information from previous tasks,
Uh-huh.
which slows things down.
So it's like a cluttered workspace that makes it harder to find what you need.
Exactly. Johan calls this pollution of the processor's resources. And Mosaic's solution is to partition these structures into smaller, function-specific tiles. It's like
Okay.
tiles on a bathroom floor.
Right.
Each function gets its own dedicated space, so its data and instructions are always readily available.
So it's all about keeping things organized and giving each function its own little compartment to work in.
Precisely.
I like that.
And the results are pretty remarkable.
Okay.
Johan's research shown that Mosaic can boost throughput by up to 225%, while also reducing power consumption by 22%.
Wait a minute. So we're getting more performance and using less energy. That sounds almost too good to be true.
It's just a really clever way of using the hardware more efficiently.
Okay.
Mosaic's performance modeling can predict the optimal tile size for different functions, so we're not wasting any precious resources. And when a function isn't actively running, its tiles can be powered down, saving energy.
That's pretty brilliant. It seems like Johan is really advocating for a fundamental rethink of how we design hardware and software for cloud workloads.
You're absolutely right.
Mm.
He believes that serverless computing has the potential to revolutionize the way we build and deploy applications. But we need to move beyond simply adapting existing technologies. We need specialized solutions that are tailored to the unique demands of serverless environments.
Right.
Yeah.
It's amazing to think how much innovation is happening in this space, but it makes me wonder, what are the incentives for cloud providers to actually adopt these technologies?
That's a great point.
Because after all, they're businesses,
Right.
and they need to see a return on their investment.
Yeah, cost savings have been a major driver for serverless adoption so far.
Right.
The pay-as-you-go model
Uh-huh.
is incredibly attractive for businesses because it allows them to only pay for the resources they actually use.
Right. No more having to guess how much server capacity they'll need
Right.
and potentially overspending.
Exactly. But when we start talking about specialized hardware like Micromanicore, the equation becomes a little more complex.
Right.
Will the cost savings from improved performance and efficiency
Yeah.
be enough to justify the upfront investment in developing and deploying this new technology?
That's a good question. It probably depends on a lot of factors, right?
Absolutely. The size of the cloud provider is a big one.
Okay.
Larger providers like AWS, Azure, and Google Cloud, with their massive data centers, might see a quicker return on their investment. They process such a huge volume of requests that even small gains in efficiency
Right.
can translate into significant cost savings.
But smaller providers might not have the same economies of scale.
Exactly. For them, it might be more prudent to wait and see how the technology develops and how the market responds before making a big investment.
Right.
It really comes down to a careful cost-benefit analysis.
So it's not a one-size-fits-all situation. There's a lot of nuance to consider.
Absolutely. And beyond the financial aspect, there's the question of how these technologies might shake up the competitive landscape of cloud computing.
Oh, interesting.
Yeah, if some providers jump on board with these innovations while others lag behind, could it create a performance gap?
Oh, interesting point. So it's not just about saving money.
Right.
It could actually become a competitive advantage.
Exactly. Cloud providers are constantly battling it out for customers.
Right.
And performance is a major selling point.
For sure.
So if one provider can offer significantly faster and more efficient serverless solutions, it could give them a real edge in the market.
It makes you wonder if we're going to see a kind of arms race with providers pushing each other to adopt these new technologies in order to stay ahead.
It's certainly a possibility, and this innovation isn't just happening at the infrastructure level. It also has implications for how developers design and build software.
Now, that's something I wanted to ask about. How might these advancements in serverless technology change the way we approach software development?
Well, traditionally, serverless development has been all about breaking down applications into these small independent functions that can be executed on demand.
Right.
But if we have specialized hardware, like Micromanicore, optimized for handling these functions,
Hmm.
It could open up new possibilities for architecting more complex serverless applications.
So we could potentially build applications with even more granular functions, knowing that the underlying hardware can handle the increased complexity.
Precisely, it could also lead to a wider range of applications being built with serverless architectures.
Okay.
So currently, serverless is often seen as a good fit for event-driven application,
Uh-huh.
like processing data from IoT devices or handling web requests,
Right.
scenarios with bursts of activity followed by periods of low usage.
Right. Those cases where you don't need servers running constantly.
Exactly, but with the performance and efficiency gains from these innovations, we might see serverless being used for more computationally intensive tasks or applications requiring real-time responsiveness, things like video processing, machine learning, or even gaming.
Wow, that opens up a whole world of possibilities. It sounds like we'll need new tools and frameworks to manage this increased complexity.
You're right, as serverless architectures evolve, developers will need new ways to monitor performance, ensure security, and handle the intricacies of these more sophisticated applications. It's going to require collaboration between hardware designers, software developers, and cloud providers.
Okay, so collaboration is key, but amidst all this focus on technology, are there any social or economic implications that we should be thinking about?
That's an important question. One potential concern with specialized hardware, like Micromanacore, is vendor lock-in.
Hmm.
If a particular cloud provider controls the design and production of this hardware, it could create a situation where developers are essentially stuck using that provider's platform.
Because their applications might not be compatible with other platforms that don't have that same specialized hardware.
Exactly, this lack of flexibility could stifle competition and innovation in the market.
Right.
So it's crucial to think about open standards and interoperability, allowing developers to have choices and move their applications between different cloud providers.
So we don't want to end up in a situation where a few big companies have a stranglehold on the entire cloud ecosystem.
Right.
And while we've talked about energy efficiency, shouldn't we also consider the environmental impact of manufacturing this specialized hardware?
You're raising a crucial point. Producing semiconductors requires significant energy and resources, and it can have a substantial environmental footprint. So as we develop these new technologies, we need to consider their full life cycle from manufacturing to disposal and strive for sustainable practices.
It's not just about reducing energy consumption during operation.
Right.
It's about minimizing the environmental impact throughout the entire process.
Absolutely. We also need to consider the potential impact on jobs.
Hmm.
As serverless platforms become more automated and efficient,
Right.
will it lead to job losses in areas like system administration and infrastructure management?
It's a classic dilemma with any technological advancement, creating new opportunities while potentially displacing existing jobs. How do we balance those two sides?
It's a complex issue. As we embrace these innovations, we need to be mindful of the potential impact on workers and invest in retraining and upskilling programs to help them adapt to the changing job market.
It sounds like there's a lot more to consider than just the technical aspects. It's about the economic implications, the competitive landscape, the environmental impact, and the social consequences.
Precisely, it requires a holistic approach to serverless adoption. We need to create a sustainable, equitable, and accessible future for cloud computing, and that requires a thoughtful and balanced approach.
I love that a sustainable, equitable, and accessible future for cloud computing now. Before we move on, there's one more aspect of Johan's work that I'd like to touch on, his research on virtual memory.
Ah, yes, virtual memory.
Yeah,
It's something most people don't think about, but it's absolutely essential for any computer system,
right.
including serverless platforms.
It's kind of like the unsung hero that enables our computers to run multiple programs seemingly at the same time.
Exactly. Virtual memory creates the illusion of having more memory than is physically available. It's a clever trick that allows the operating system to manage memory allocation and make the most efficient use of the available resources.
Okay, I'm intrigued. How does Johan's work come into play here?
Well, traditional virtual memory systems are designed for general-purpose computing,
Okay.
where applications can have a wide range of memory needs and access patterns.
Mm-hmm.
But serverless environments, with their small, short-lived functions, often have very different memory requirements.
So it's another example of how traditional computing concepts need to be reevaluated in the context of serverless architectures.
You got it. Johan's research explores ways to optimize virtual memory systems specifically for the unique characteristics of serverless workloads.
What are some of those unique characteristics?
Well, as we've discussed, serverless functions are usually small, have short lifespans, and often exhibit burstiness in their memory usage.
So they need a virtual memory system that can quickly allocate and deallocate memory, handle sudden spikes in demand, and minimize overhead.
Precisive Johan's work explores innovative approaches to address these challenges, including techniques like demand paging memory ballooning and page sharing.
Those sound pretty technical. Can you break them down for us?
Of course, demand paging is a technique that only loads pages of memory into physical RAM when they are actually needed.
Okay.
This can greatly reduce memory usage, especially for functions that only access a small portion of their code or data at any given time.
It's like a just-in-time delivery system for memory.
Exactly. Memory ballooning is a technique that allows the operating system to reclaim unused memory from applications.
Okay.
Including serverless functions, it's kind of like squeezing a balloon to push out air and free up space.
That's a great analogy. And what about page sharing?
Page sharing allows multiple serverless functions to share the same physical memory pages if they contain the same data. This can be especially beneficial for functions using common libraries or frameworks, as it reduces the overall memory footprint and improves efficiency.
It's like a carpool for memory pages, reducing the number of chips needed to access the same information.
I like that analogy. These are just a few examples of how Yoan's research is pushing the boundaries of virtual memory design for serverless environments.
It's fascinating to see how this often overlooked component plays such a crucial role in making serverless platforms efficient and scalable.
Absolutely. Virtual memory is a key piece of the puzzle, and Yoan's work highlights the need for innovative solutions that are tailored to the specific demands of serverless computing.
So we've covered a lot of ground today, from specialized processors and energy-efficient software frameworks to the intricacies of virtual memory management.
Yeah, it's clear that Yoan's work isn't just about making serverless systems faster and more efficient. It's about shaping the future of cloud computing itself.
I think that's a great place to pause for. Now join us in part 3, where we'll wrap up this deep dive with some key takeaways and a thought-provoking question to leave you pondering. Welcome back to the show. It feels like we've been on this incredible journey,
It has been a journey.
exploring the future of serverless computing
Yeah.
with all this groundbreaking research from Jan Stokovich.
Yeah, it's been a fascinating deep dive into some really groundbreaking ideas.
Absolutely. We've gone from, super fast processors designed for serverless workloads
Right.
to energy-saving software, and even reimagined how virtual memory works.
Uh-huh.
So what does it all mean?
Right.
What are the key takeaways that you think our listeners should walk away with today?
I think the biggest takeaway is that serverless computing is about so much more than just convenience or cost savings. It has the potential to be incredibly powerful, efficient, and sustainable.
Right.
But to get there, we need to completely rethink how we approach both hardware and software design.
It's not just about slapping a serverless label on existing technologies.
Right.
We need to build from the ground up with serverless in mind.
Exactly. And John Yoan's work really shows us that this shift is already happening.
Right.
Whether it's Micromanicore's innovative processor architecture, Echois's intelligent use of slows to manage energy,
Right.
or Mosaic's clever way of maximizing existing hardware.
Right.
We're seeing some truly ingenious solutions emerging.
And it's not just about the technology itself, right?
Yeah.
We've got to think about the broader implications.
Yeah.
These advancements in serverless technology have the potential to reshape the entire cloud computing landscape,
For sure.
influencing everything from the competitive dynamics between providers to the very way developers build software.
It's a ripple effect
Yeah.
that extends far beyond just the technology itself.
Right. We need to consider the economic factors, the environmental impact, and even the social consequences of these changes.
Absolutely.
It's complex.
It's a complex
and interconnected system.
interconnected system.
Yeah, so it really highlights the need for a holistic approach, right? We can't just focus on building the fastest or cheapest solutions.
Right.
We need to think about sustainability, accessibility, and the long-term impact on the workforce.
Absolutely. It's about creating a future for cloud computing that benefits everyone, not just a select few. It's an exciting challenge, and I'm optimistic that by working together, we can harness the incredible potential of serverless computing to build a better future.
And that leads me to a final thought-provoking question that I want to leave our listeners with.
Okay.
We've talked a lot about the technical side of things.
Right.
But what about the human element?
The human element that's often the missing piece of the puzzle, isn't it?
Right. As serverless platforms become more automated and sophisticated, where do humans fit in? Will we just be managing and orchestrating these systems, or are there new and exciting opportunities for creativity, innovation, and problem solving?
That's a great question, and honestly, I don't think anyone has a definitive answer yet, but I believe that human ingenuity will always find a way. As technology evolves, so too will the nature of work. We'll need to adapt, learn new skills, and find new ways to contribute.
Well said, and that's a perfect note to end on. Thanks for joining us on this deep dive into the world of serverless computing. It's been an incredible journey exploring the cutting edge of cloud technology and contemplating what the future holds.
It's been a pleasure. Keep exploring, keep learning, and keep pushing the boundaries of what's possible.